To actually join testnet, first thing you need to do is go into the website brainstorm.invarch.network. Here you'll find the faucet, which is where you get your tokens. If you have an extension, like for example I have Talisman, you could also have Polka.js, for example, in your browser. Your accounts are going to show up here, and they're going to show up in this list. If you don't have an extension but you do have your account, it makes more sense if you do have the extension, because then you can use it in Polka.js in the same browser. But even if you don't, you can type your account here in this field, or if you have the extension, you can select it here, and you can click the button to get tokens. And let's see the balance here. You can see that it's going to update as soon as the transaction actually goes through. So it's being broadcasted. Okay, it's in the block, and the balance up here updated. Alright. You can see the accounts in the accounts tab. This account has the balance that shows up there. In a network explorer, you can see the blocks being produced, the events with the transactions. Here's the transaction that got me the balance that I just asked in the faucet. And the main stage here will be the developer tab, more specifically the extrinsics tab and the change states tab. Also for adding files to IPFS, this files tab, this is where you can upload files to IPFS for free without having to run the IPFS nodes in your own computer. Chain state, again, this is where you can see data that's on chain, and extrinsics is where you can run calls and execute functions, for example the InvArch functions. And this is where we get to the main differences from the last testnet, and also from the last workshop that we did, the first part. In the last workshop, the part 1, we had Ballot IPS, Ballot IPL, Ballot IPT, and Ballot IPF. Okay, those first 3, IPS, IPT, and IPL, they are always going to be together. So what we end up doing is we ended up merging them into a single InvArch palette to actually improve a lot the performance and the storage space that we use. So now the palettes are a lot faster, and they use a lot less space. In InvArch, you still find the same functions that you would find in the palettes APS, APT, and IPL. For example, the create APS function that you would find in IPS, and where is it? The IPT mint function that you would find in palette APT. They're all here inside the same palette. IPF is still a separate palette because IPF is not dependent on any of the InvArch palettes, the previous InvArch palettes. It works fine independent, so IPF is still separate. One more thing that we added, RMRK palettes. We're going to skip over RMRK equip for today, but RMRK core. This is the RMRK version 3 palettes, and you can mint NFTs, create collections, and all that. You can do all RMRK operations here, and as bonus, you can add RMRK collections and RMRK NFTs inside APSs. So let's start by demonstrating that. Okay, let's go to RMRK core. Let me actually duplicate this first, just so we can stay in the Network Explorer to see the events, because we're going to need the events to continue here. Let's create a collection. Let's metadata. Let's just give it a name. Let's call it Gabe's Awesome Collection. I don't know. And symbol. Let's give it GAC for Gabe's Awesome Collection. Submit transaction, sign and submit, and my wallet pops up. Can approve that, and there we go. We can see the events. We can see that a collection was created, and the ID of the collection is 1. So that's why we needed the events. We need to see the IDs. Now let's mint an NFT. Let me first come here to files IPFS. Here we have let me actually add a new file here. Let's add my Discord and Twitter profile picture. It's in documents, Kios Red v3. Let's do it this way. Let's sign and upload that. Wait for the loading bar. There we go. And there, finished. So we have this IPFS file, and we can copy the CID. So the main difference actually not the main difference, but the first immediate difference you find between a RMRK NFT and an IPF is RMRK NFTs, they need to be in collections, and second, they have free metadata. So what does this mean? The metadata for IPFs, we needed to convert that to a CID hash, because CID hashes are the universal way that IPFS understands the identifiers, the addresses, and CIDs are just the way that we convert them so humans can read. But in RMRK, in a RMRK NFT, you don't have to use the hash. You can actually just use the CID because the metadata is not intended to be specifically for this use case. And a metadata in a RMRK NFT is not always going to be an IPFS file. So you can just add the CID here without getting the hash. So we're going to mint an NFT, collection ID. We're going to use the one that I just created. I'm going to be the owner. Transferable, yes, we want this to be transferable if we want to put this inside an IPS. So let's submit transaction, sign and submit. Approve. There we go. NFT minted, and it's collection 1, NFT 0. NFT 0 because this ID is based on the collection, so it's not going to be if there's already another RMRK NFT, it's not going to conflict with this. Okay, let's go back here. Now let's create an IPS. So we go to IV4, create IPS, metadata, we can use anything here. Let's call it Gabe's awesome IP set. And here in the assets, we can add multiple items. Let's start by adding a RMRK NFT. It's so this is these two values. The first one is the collection, second one is the NFT. So we're going to do 1 and 0, collection 1, NFT 0. Let's not allow replica. Let's leave the license as it is. We're not going to touch that in that today. Ipl Execution Threshold. This is important. We're going to set this to 0.50, which means that we need 50%. We need over 50% votes for Multisigs to execute. So this is like if we had 100 people having exactly 1 in voting power each, we would need 51 people to execute a decision. And I always like to do 50 because it's a pretty common value and understandable even outside of crypto. Businesses with boards of directors usually have voting at 50 to over 52. IPL default asset weight, we want to set this to 0.0. So this will actually give by default every sub asset will have no voting power, but we can then modify that with multisig calls. We can modify that after effect. And also the same for IPL default permission. We don't want any sub asset to have any permission because we want to specify which calls they can run. If we leave this as yes, what we could do then is specify which calls they could not run. So we want to leave this to no and have complete restrictions, and then we will set our permissions manually. Okay, let's submit transaction, sign and submit, approve. There it is, inv4.created. We can then go to change state. We can query that in inv4 IP storage. Just a reminder that this used to be IPS storage and also IPT storage and also IPL storage. Here's one of the benefits of having them all unified. It saves a lot of storage space to just have one IP storage that has all that information from all three. So let's query number one. Sorry, is it number one? Yeah, number one, yeah. There we go. Metadata, Gabe's awesome IP set. Data, we have a RMRK NFT. And we also have the IPL and IPT data. Supply 1. So supply 1 means we have one token in our asset. Let's go to balance. 1 and no option. This option is to specify if we want to query balances for a sub-asset. If we don't specify this, we are querying assets for the root asset, which is the asset that usually represents ownership. Let's check the balances for me. And there we go, that one balance that we have total supply 1. So this is actually a U128 value, which means that it can be a pretty large value. It's the same type of integer that we use for normal chain balances, and the reason we use such a large integer value is that we usually have that as a fixed point type for having decimal points. So let's say we want to have a balance that also has 5 decimal points, and we want to represent one unit 1.0, and that balance with a U128 we do 1, 2, 3, 4, 5 zeros. This would represent one unit 1.0 if we consider that it has 5 decimal places. This is all up to whoever is making their IPSs. We start at 1. We just keep 1 at the start, and then you can mint more or burn however many you want. This is all up to the IPS creator. Okay, let's continue here. Let's go to string 6 again, and now let's also demonstrate that we can add. Where is it? Let's demonstrate how to add the one remark collection we created inside of the APS, which is something we can also do. Let's do operate multisig. This is how we run multisig calls inside of IPSs. Right now, the only person that has any assets, has any balances, any ownership is myself. I have 1, and I need at least 50% of the total. I have 100% of the total, so that's going through without any voting. So for adding things, we need to include a caller. So let's include the caller, because then the multisig call will understand that I'm the one calling and check that I have the collection. IPTAD, this is the same as the IPS ID. We just use 1 here, and we're not going to use any options because we want the one that represents ownership, which is the one that I have. And then the call here, we can do inv4 append. We have to give this the 1 again, IPS ID. And here in the items, the assets, we can actually click this and select remark collection. And that collection was 1, right? Yeah, collection 1. So let's do that. Submit transaction, sign and submit, approve. See if it goes through. Okay, in block. Here it is, InvArch appended. Now let's go back to chain state. InvArch, IP storage, 1, and if we query that, there it is. We have data inside of this IPS, a RMRK NFT, and a RMRK collection. So in a situation where either a dev developer or just like a normal user wanted to represent the IPS wrapping over RMRK collection for tying both ownership over the assets and also licensing over them, we would actually end up using just a RMRK collection, because then what this means is that you can still sell ownership of the NFTs themselves. You can still sell them, but the overall collection, which is the originator of them, is still wrapped in the IPS that you have ownership and that has a tied license to it. Okay, let's proceed with more features. We're going to demonstrate now how to do subassets and permissions. Let's go to extrinsics. So, going to InvArch, operate multisig again. This time we don't need to include color because we're not adding any data inside of it, not appending anything. Okay, 1 here, or IPS 1. Now what we want to do is, with a multisig, we want to call InvArch create subasset. Alright, and what we want to do here, let's actually give a DED. And we want to give the subasset its own ID. We can choose anything we want here. Let's keep it as 0. And metadata, this is just to have a description on chain of what that subasset will represent. Let's see, what are we going to do here? Let's just call it users. I don't know. And let's give Bob. Sorry, we don't have Bob. This is a deploy chain. Let's give my second account, Gabe 2. Let's give me also 1 token. And submit transaction, sign and submit, approve. Broadcasting, in block, multisig executed, subasset created. Here we go. Now let's keep the same operate multisig base here, and let's just change the call to set permission. Okay, so setting permissions, we have the default as no, not having permission. So let's set a permission for a specific call for a specific asset. So my IP is number 1, and I want to set a permission for the asset 0 that I just created. Call metadata. Okay, so this is where you define which call you want to define permissions for. Let's use this this tab that we have here to go to extrinsics again. Let's check the system.remark with event. This is just going to display a text on the events thing. So this is a very simple call. Let's just write here text just to display here. So when you are in this extrinsics tab in Purple.js and you have a complete call, you can submit it, but you can also check here in this part here of the screen, encoding details, call index. This is what you want. This is 0008. This is the call metadata, the call index for the system.remark with event. So what we want to do is go back here, call metadata. We have to start with 0x because this is a hexadecimal. So 0008. Okay, and permission, we're going over WASM later. Let's keep it at a bool right now. Boolean, this is either yes or no. Let's give it a yes. Let's actually, before we do this, let's let's head over to, let me just leave this one at Explorer, just because I want that in there. Let's go to extrinsics in a separate tab. Let's demonstrate what happens right now if I do with my secondary account, the one that has the sub asset. If we do operate multisig, I have to do one here, and then this account, they don't have any of the root asset. What they have is the sub asset ID 0. So we include this option, and we use the 0 here. Let's do system dot remark with event. Let's do anything here. Let's try type the test that we had before. Submit transaction. Sorry, this account doesn't have free funds. Let me just real quick get some funds into this account. Otherwise, you cannot pay for transaction fees. There we go. Has funds now. There we go. And let's see what happens. Watch here in the corner. Sub asset has no permission. That's what happens. So let's complete this now. Let's set the permission to that call to yes. Submit transaction. Sign and submit. The events. There we go. Multisig executed. Permission set to true. So now if we do that again, submit transaction, sign and submit, approve. Now instead of the error, it should just go through. There we go. It's in block, and we can. Sorry, the event didn't show up. Oh, sorry. Yeah, right. Because this account doesn't have enough voting power to actually execute it, but now they have permission to start the voting, which means I can now copy this hash. This is the call hash, the call they just did. They're trying to do as the IPS account, and then what we can do is we can head over here with my account that actually has voting power. Instead of operate multisig, what I can do is I can vote multisig. Vote with my asset 1, call hash, bam, submit transaction, sign and submit, approve. Ooh, invalid. Okay, that's a bug. I'm going to have to look at that in a second. Yeah, that's going to be. Yeah, I have to fix that later. Let's just do it with this call. Let's just do operate multisig instead of vote. I'll fix that as soon as we finish the workshop. Okay, include caller no. 1. System dot remark with event. Actually, instead of doing this, let's give that account voting power. Operate multisig. IV4. Set asset weight. This is how we give that account voting power. That asset voting power. So it will be IPL1, so IP1, IPS1. Sub asset is 0. And let's see. We need 50%. We have 2. So if we give that account exactly 1, the same as the asset that represents ownership, they should have enough. Actually, no, they won't have enough because that would need that will need 50. That would need 51% over 50. So before we do that, let's give that account more. Let's IPT mint actually of subasset 0. Let's give them one more. Here we go. Submit transaction. Approve. There we go. Minted. Now let's set right here. Now let's set their asset weight to 1 again. One, so asset 0. There we go. Okay, now they can properly operate this. Let's submit transaction. Ooh, multisig operation already exists. So let's first actually withdraw the vote, just so we clear that. Where is it? Here. Let's clear that first. There we go. Multisig cancelled. So let's start a new one now with operate multisig. 1 and 0 here. System.remark with event. Test. Submit transaction. Sign and submit. Approve. There we go. Multisig executed. And system.remarked. One chain remark happened. There we go. So yeah, we demonstrated that it works with the Boolean Boolean permissions. So now let's explore what the WebAssembly permissions are. To do that, let's actually start a new. Let's start fresh. Let's create a new IPS. Let's go to create IPS, test, and just to be simpler here, I'm not going to add any assets inside of it. Just leave it at that. You need 50%. So let's leave it at 10, just because it's easier like that. Default permissions is set to no. Default asset weight set to 0. Creating. Approve. Video laggy. So some people are complaining that the video is laggy. If you mean that it takes 20 seconds, that's normal. That's Crowdcast takes 20 seconds from when I say something for it to actually show up in your side. That's just the normal lag that Crowdcast has. So here, to Explorer, we create a new IPS ID 2. All right, let's go to. Sorry, let's go back to extrinsics. Let's operate multisig. 2. IV4. Create subasset. 2 here. ID 2. Sorry, no ID. Let's give it ID 0. So let's call a sub asset 0. Let's give my secondary account also 1 token. Let's sign that and submit. You can track here in the events, and that goes through. There we go. Subasset created, and here's the interesting part now. 2 subasset 0. Let's demonstrate what I already have here on hand, which is the balances dot transfer. Okay, so balances dot transfer. It's call index 0A00. let's do that. 0x 0a00. Instead of Boolean now, let's use WASM, WebAssembly. And we're gonna want to take the file upload here. But before we upload that, let's see what we want to define there. So the way that WebAssembly permissions work is we have the arguments for this call. So here, for example, the balance.transfer call, we have the account ID and the value of the transfer. These are the arguments. What we're doing there is that we're putting those in the WebAssembly of virtual machine memory, and then we run the WebAssembly function that the user provides, and we expect the output to be either 1 or 0. If it's 1, then we consider that as permission granted. If it's a 0, we consider that as permission denied. What it means is that it can write any sort of logic you want inside of that WebAssembly function, manipulating the memory content, which is the function or the call arguments, and based on those you can write any sort of logic to either return a 0 or 1. So let me just demonstrate a real quick one that only returns a 1. So it only allows the call to be executed if this amount is exactly 69. So here, let me demonstrate what happens when I have, for example, a 68. Sorry, let's do 58 or a 58. You see the end here. So we know these are the last two values. You can see here a value actually. It's a E8. If we change that to 69, then the value changes to 1501. Okay, and these are 2 bytes now. So we know that actually when we convert those from hexadecimal to just bytes, they become 2101. So we know that we need to expect the last 2 bytes to be 2101. Anything else, we can just reject that call. We can say that we don't have any permission. So let's come over here. This is assembly script. It's a JavaScript, actually TypeScript, that compiles to WebAssembly. And this is a pretty simple function. It's a function called C. So right now, how we have the WASM permission set up is we expect a function that's called C, just a letter, because that uses way less space. So we call that function with the name C. So we can actually put a bunch of other functions if you want to, if you need more in your WebAssembly code. But the one function called C is the one that that's going to be executed and that we expect a 1 or a 0 in return. You can have one argument in there that's the length of the memory area where we have the data, the actual call arguments, because we don't always use the whole memory, so we give the length because, for example, we want to know that those last two bytes for the balance transfer call, so we need to know where they are. If they are not in the end of the memory, we need to know exactly how long those arguments are to check where they are. And then we also return an integer, 32 bytes. So this is pretty simple. If, and then this load function in assembly script, it fetches data from memory. So we are loading this length. This is automatically going to be the last byte in memory, the last byte in the arguments, which, as I said, it has to be 21 and then 1. So the last byte has to be 1. The one before has to be 21. So if that byte in memory is 1 and the one before it, length minus 1, is 21, then we return 1. If they are not, we return 0. Pretty simple. When we compile this, let me compile that real quick. So if we compile that, here in build, we're going to use this file. So it compiles to Actually, it only we are only compiling. We are not compiling with release. We're only compiling this .web file. So we're not compiling to WebAssembly yet because we need to change some things here. Okay, so here to untouched.what. We're going to change a couple things there. So right now in assembly scripts, there's no way to, I don't know, at least I couldn't find it, a way to specify the import memory. So we have to compile with -- import memory, and then it creates this and this. A couple of things we need to change here. First, we don't want to export memory. That's only going to waste space, but we don't need exported memory, so we can just delete this line. And here, import env memory. Also to save space, the way we declare memory on chain is module is called E instead of env, and the link's called M instead of memory, and that saves a lot of bytes. I mean, if it's a really big code, it's not that much, but it's the difference between 80 bytes and 60 bytes. So in the for smaller size code, that's a lot of bytes saved. Let's save this, and then let's actually convert that. Sorry, I have here. Let's convert that back to WebAssembly, and I'm saving this to this asm.wasm file. We can check the size of that. That's 68 bytes. So it's really small, and all it does is that one simple thing. If the amount of balance being transferred is 69, give permission. If it's not 69, don't give permission. That way we can further customize. Instead of just saying you can perform a balance transfer or you cannot perform a balance transfer, what we're saying is you can perform a balance transfer if and only if all of these programmed parameters are passed. So we can further customize all those permissions down to every single byte of the arguments. So I also have here in this other terminal a separate runner that's not on chain, but it's the exact same code that we have running on chain. And if I run that, it's going to say, so I have the arguments already set for a balance transfer call, returning 69, transferring 69, and we see the return value as 1. Here, if I open that file, and let's see, these are the arguments. So 1501, just like they are on chain. If I change them to, for example, 1601, and I re-execute this, value is 0. So sure that it works. Let me change this back to 1501, and let's try that. Actually, let's upload that here. It's right here. WebAssembly. Let's add that asm.wasm, 68 bytes. There we go. Submit transaction. Sign and submit. Approve. There we go. Multisig executed, permission set to WebAssembly. Okay. Now let's come back here to this account, and let's do inv4 operate multisig 2 and subasset 0. Let's do that. Let's do balances transfer. So let's transfer to myself. Let's try to transfer 10. Submit transaction, sign and submit, approve. There we go. Subasset has no permission. But if we change this to 69 now, it should work. Approve. There we go, it worked. It's in block. Multisig vote started. Balance transfer value 69. See, as easy as that, you can make WebAssembly permissions, and it's not only in assembly script. You can, if you want, you can manually write them in WebAssembly text format, which is this. But you can see the difference. So here's just like if load from memory 1 and load from memory equals 21, return 1, else return 0. And WebAssembly text format is a lot harder to read. So you have to get that from get the parameter, and then you have to load, and then you have to do a bunch of operations like this. The main problem with WebAssembly text format is that it's all stacked, and there's no real way to define what actually is happening in the operations and orders or anything. You just have to stack text like this. You can also write it in Rust. You can write it in anything that actually compiles to WebAssembly, which is like mostly most languages, most popular languages do have some sort of WebAssembly compiler, and it's all pretty simple to write. So this is that one that we used. For example, before I had written this. This is the same thing, but I wrote this in WebAssembly text by hand. It does the same thing. This just happens to be 80 bytes, and the one that I compiled from assembly script is 68 bytes. And we can do a lot more customizability with this. Let's see. Let's try to think of something else to demonstrate with that. Let's take a look at the calls, actually. We can do, let's see. Let's actually try a RMRK call. So let me just get the data here. So system.remark, and let's write text. So the call index is 0001. Okay, let's do that at the same time here. Operate multisig, set permission to 0x0001. Okay. And then so let's see. We have that, and then the only data being sent is this remark. Let's see what happens if I only have a 0. Okay. So we know this is what's going to be there. Let's actually make this a bit simpler. Let's just have an I for InvArch. An uppercase I. So bytes are going to be 0449. Let's copy this. Copy this. Let's go back to that one script I have that runs this. Let's change the arguments to that. Wait. Let's change the arguments to but actually we don't want the 0001. We just want that. So let's see. If we go back to this and we do, let's actually first, before we try that, let's just comment this all out, and let's return the last thing in the memory in the arguments. That way we can print this here and see the value that we need. So let's actually recompile that first. There we go. And let's run. Okay, RX473. Are we adding those correctly? Let's actually print the length just to see that it's going correctly. It isn't. Oh, actually, because sorry, I forgot. We have to. I forgot we have to do this actually. Compile this first, and then change the memory here. Pretty annoying, but we'll soon fix this too. Okay, there we go. Now we can send that and can run it. There we go. 7.3. We know the last has to be 7.3, and the one before has to be 4. So we can just revert that. If the last is 7.3, the one before is 4, return 1. Let's file that. There we go. See if that works. And oh, I again forgot to do this. Happens all the time. In Rust, this probably wouldn't be an issue, but I'm just using sample script because it's simpler to demonstrate actually. Here we go. And toggle run. There we go. Value 1. If we change, where is it? If we change one of these arguments, be 48 for example, and value 0. There we go. Now we have this functioning, this asm.wasm. The call is 0001, so let's upload that, the new one. Here we go, submit transaction, sign submit. And this will actually validate your code when you submit it. So if, for example, I hadn't changed this as I had, it wouldn't work here, and at the same time it would also not even be inserted on chain. So it would give you an error when you try to set permissions saying that the WebAssembly is malformed, that it wasn't in the correct format. So now that we set that, system remark I, uppercase I, let's do that. Let's try IV4, operate multisig, 2, 0, system.remark, let's do lowercase I, submit transaction, and that should not work. There we go, subasset has no permission. Uppercase I, this should work now. Again, it might not because we're doing this live and there's always something in code that doesn't, oh, but it does. There we go. Just to demonstrate, it's as easy as that to write custom permissions. So there we go, Multisig vault started, system.remark with arg remark uppercase I. So again, it's as simple as writing some very simple WebAssembly code in any language you want, compiling that to WebAssembly bytecode, and then inserting that to chain. And then you can start running your permissions. It's and this allows you to do any sort of logic you want here. Anything you can define with code can be done in inside of these lines here, these lines. And all you need is to return a 1 or a 0. So it's as simple as that. Even if you wanted to just, I mean, it wouldn't make any sense, but if you wanted to just do a yes or a no, simple boolean, you could just write WebAssembly that returns a 1 or returns a 0, fixed. But just to demonstrate how powerful this is, it has no limits. Well, besides character count, which right now in Brainstorm is it has to be at most 1 kilobyte, but as we just saw, this simple one that I just demonstrated here, it has 69, I think, bytes. So in Brainstorm you have 1 kilobyte per WebAssembly module, and that's enough to do a lot of stuff. And I didn't even optimize this, so that's a lot of potential. Let's see if I have any comments. Do you have any questions? Anything you guys want me to go through again or explain about the testnet? Let's wait a few minutes here to see if anything comes up in chat. Okay, so while you guys come up with any questions, if you have any in chat, I just want to sorry, just a second. Okay, so I want to remind you guys that all of this you are seeing here, this is just in the Brainstorm testnet right now, but it will all be available in the Tinkernet and the Kusama parachain that we're going to launch, and the crowd loan for that is going live in the 42nd batch. Let me actually open up here, parachains.info, and so here, auctions, Kusama. Here we go. Tinker parachain. It's going live in the 42nd, which is the very next, in this batch, the first of the very next batch. 41st auction ends June 26th, and I'm not sure exactly. I believe it starts in the 29th of June. Dakota can confirm that in chat, but at the start of the next batch we will be live with our crowd loan, and it will be pretty interesting to see the responses from the community. But if you want to get some tokens to actually start running things like this in the real world with outside of the testnet environment, you can contribute to the crowd loan, to the Tinkernet parachain crowd loan, and then you get the crowd loan rewards, which you can use to run operations like this on chain, on the actual deployed to Kusama parachain. And all this tech that I just demonstrated here, all of this will be available from the start on the Kusama parachain. Yeah, and just like Dakota mentioned in chat, we have updated the Tinkernet tokenomics. So we have that article he posted in chat. If you guys want to check out the new tokenomics, go read that article. It was published less than 24 hours ago, so it's pretty new. And also, I want to remind everyone that if you haven't yet, you can verify your attendance to be if you don't verify, you won't get your NFT. So click the button that we have right here. You guys should be able to see verify your attendance button on screen, and that will take you to a Google form that you can fill with your details to confirm that you were actually here in the workshop and get your NFT. And I also want to let you guys know that all of this that I showed, for example, this script that tests the permission WebAssembly outside of the chain, this will all be available eventually in the SDK tools from that we released for InvArch. It won't be available immediately on launch, but soon after on Kusama. And any actual questions that you guys have that you if you want to work on this and don't know exactly how to, we can chat in Discord. We can help you guys, and you can test everything in Brainstorm, and then later you can launch things on Kusama on our Tinkernet parachain. Okay. And also I wanted to mention a couple more of the possible use cases for IPLv2 for the WebAssembly permissions. Imagine if you have, for example, the ambassador, the InvArch ambassador. Sorry, I forgot the word. So you have the ambassador program running on chain, and you wanted to only give permission for. So if you have a subasset that's dedicated for people that submit articles, if you only wanted them to submit articles, you could write WebAssembly a WebAssembly permission that only allows them to call the only allows them to call the append function to add data to the IPS if that data is a text file, for example. It can go there in that depth, but it can also go a lot lower level by letting you control permissions for XCM operations, for cross-chain messages. So if you wanted to, for example, control permissions for running calls to a file effect contract, you could also make custom permissions for that. You could do a whole bunch of stuff by having all your actual control logic, your actual DApp logic in a smart contract. You could even run in a whole different chain, and then you could have a DAO on InvArch where you save data, where you authenticate data, and control permissions and control access to that DApp, to the contract, by making custom permissions for the DApp calls, the contract calls. This goes a lot deeper than just a simple NFT collection. This evolves a lot from that point, but it also wraps NFTs. So you don't have, if you are an artist, for example, and you have NFT collections, you don't have to drop all that to have your stuff on InvArch. You can just, for example, use RMRK and wrap around your collection, and then suddenly your RMRK collection gets all the power. So the idea here is that it's very composable and flexible to accommodate the things that people are already doing. So you can just come to InvArch and experience the same thing you were experiencing with RMRK NFTs, for example, and on top of that, have a lot of power on top. Okay, so I guess we already went past the allocated time. So yeah, we can wrap it up here. Again, reminding you guys to go check the new tokenomics, go research the crowd loan. That's very important. It's coming up, and also verify your attendance by filling out the form to make sure you get your NFT. All right. I'm going to see you guys hopefully in the Discord to answer all your questions if you have any. So that's it.